Welcome back to the Physics guys, and in today's video we will discuss about one of the important concept of class 9 chapter 8 motion, and the topic is acceleration and deceleration. So let us start the session. As you can see, the term acceleration or deceleration can be understood with the help of these 6 to 7 points, as you can see on your screen. So I will be describing each and every point separately. So first of all, let us start with the basic part, and basic is the definition of the acceleration. If I want to define acceleration, so the acceleration of one body is defined as the rate of change of velocity with respect to time. Okay, so it is the rate of change of velocity with respect to time. So basically the acceleration term can be given as a ratio of change in velocity and change in time. So acceleration is none other than ratio of change in velocity, generally written as a delta v. Delta shows the change, delta v means change in velocity, by change in time. Change in time is written as a delta t. In order to understand, let us consider this figure on which two cars same. In order to understand, consider the car which is traveling from one position, let us say this position, to this position, as you can see on your screen. Now consider that initially at time t is equal to 0, that is called initial time ti, it is here and it is traveling with the velocity u. That means u is the initial velocity of the car, and after some time, at final time, let us say tf is equal to t, it reaches here and its velocity is v. So v is the final velocity. So if I want to write down what is the acceleration, then acceleration is equal to change in velocity by change in time, means final velocity minus initial velocity divided by final time minus initial time. Okay, so final velocity here it is a v, initial velocity is u, so v minus u. Final time, if I am writing tf, and initial time is ti. Our condition shows that initial time in physics generally taken as a 0 second and final time is taken as a t second. So if I will apply it here, the acceleration a is equal to v minus u upon t minus 0, which ultimately leads us to the conclusion that acceleration is equal to v minus u upon t. Okay, so this is the equation of the acceleration. It can also be understood as a mathematical expression of the acceleration. So acceleration a is equal to v minus u upon t. Okay, let me tell you, the acceleration is a vector quantity. As we know that the velocity is a vector quantity, so acceleration is a vector quantity, Why? Because velocity is a vector quantity. Because of the velocity, as you know that in the expression itself, acceleration is equal to change in velocity by change in time. So if you measure the change in velocity, it has to be a vector, so acceleration is a vector quantity. Now let us understand the unit of acceleration. As we know that acceleration a is given by v minus u upon t. V is velocity, final velocity, u is also initial velocity, okay, divided by t time. So if I want to write down unit of acceleration, then it will be unit of v minus unit of u upon unit of t. As we know that unit of v and u is a meter per second and meter per second. So if you will subtract the two values having unit meter per second, its ultimate unit is meter per second and unit of time is also second. So unit of acceleration is meter divided by second square, that is generally written as a meter per second square, or sometime it is written as meter into second minus power 2. Okay, so meter per second square is the unit of acceleration. So the acceleration is the having SI unit of meter per second square. Other units which can use units are centimeter per second square, okay, kilometer per hour square, okay, like that. So these are the two other units which we are widely using in the physics. Now if I want to define what is 1 meter per second square. What is 1 meter per second square acceleration? Definition. If I want to find out 1 meter per second square, let me give the example that we know that acceleration is, if we require 1 meter per second square, then the change in velocity by change in time, that has to be 1 meter per second, okay, by 1 second. So if the ratio is having value of 1, then I can write that acceleration is 1 meter per second square. So ultimately I can write that 1 meter per second square is the acceleration when change in velocity is 1 meter per second and time taken is 1 second. So I can define it here that 1 meters per second square is that amount of acceleration when change in velocity of an object is 1 meter per second every second. Okay, so this is the definition of 1 meter per second square. Now in order to understand how to visualize this change in velocity by 1 meter per second every second, so for that case let us consider this is the surface on which one of the ball is rolling. I am drawing here the same ball for 2-3 different positions, and let me explain you. So here according to the definition of 1 meter per second square, if this ball possesses 1 meter per second square, let us say its time t is equal to 0 here, time t is equal to 1 second, time t is equal to 2 second, and time t is equal to 3 second. So I have shown the position of ball at various seconds. So if this ball possesses 1 meter per second square acceleration, then its velocity will be, let us say, initially 0. If velocity of the ball is initially 0, then its velocity changes by 1 meter per second every second. So from time t is equal to 0, if the ball is at time t is equal to 1 second, has a velocity of 1 meter per second. Now again the velocity will increase by 1 meter per second. So at time t is equal to 2 second, velocity of ball will be 2 meter per second. Okay, again after 1 second, the time t is equal to 3 second, the velocity of the ball increase by 1, means now the velocity is 3 meter per second, and so on. So as you can see that ball is having velocity from 0 meter per second, its velocity increased by amount of 1 meter per second, then after 1 second it is 2 meter per second, after 1 second it is 3 meter per second. So in that case we can say that ball possesses acceleration of 1 meter per second square. Okay, so ball has acceleration of 1 meter per second square. So this is the definition of 1 meter per second square acceleration.